All right. Good afternoon, everyone, and welcome to the Thelma Hansen Symposium entitled Trees to the Rescue, Solutions for Climate Change. Today, we will focus on trees as a tool for climate change mitigation and resilience. My name is Annemiek Schilder, and I'm the director of the Hansen Agricultural Research and Extension Center in Camarillo, California. And the Thelma Hansen Symposium is held annually to bring science on pertinent issues in agriculture and natural resources to our stakeholders and the public. This symposium is held in honor of Ventura County farmer Thelma Hansen, who went to UC Berkeley in 1915 to study mathematics, after which she returned to the family farm in Satakoy to continue farming. And upon her death in 1992, she left her farm and estate to the University of California to support agriculture and natural resources in Ventura County. So Thelma was a conservationist at heart. She loved the redwoods and in her life made several trips to see them in Northern California. In fact, there is a 5-acre tract in her name dedicated by the nonprofit organization Save the Redwoods. Therefore, we think that she would be particularly pleased by this year's theme on trees. So we'll first start with opening remarks by Matt Levere, who is our Ventura County Supervisor for District 1.
County Supervisor here on the Ventura County Board of Supervisors. And welcome to this really informative symposium, Trees to the Rescue, Solutions for Climate Change. Thank you for taking time out of your busy schedules to take part in these next few panel discussions where you are going to hear from leading cutting-edge experts on climate change and the role that trees play in combating the impacts of climate change. Here at the County of Ventura, we're taking this issue incredibly seriously. We recognize that Ventura County is one of the fastest warming areas on the entire planet, and that we as government have a role to play in changing that. And we're doing a lot of things to try to blunt these impacts, starting with electrification. We at the county are really trying to electrify as many of our buildings and trying to incentivize private landowners, business owners, residents to electrify their properties as well. Here in the county of Ventura, right now, 30% of our energy usage comes from solar. And with a new solar canopy that we're building here at the Government Center, in the next year or two, it's going to be closer to 70% of all of our energy usage is going to be from solar. We're looking at our fleet. Obviously at the county, we have a huge fleet of vehicles. And right now, 70% of our fleet is electric hybrid. In fact, we just got an award, a national award, where we were named one of the top 5% greenest fleets in the entire country. And beyond that, it's trees. It's what we're all here for, trees. And trees play such an important role in combating climate change. They remove carbon dioxide from the air, they store carbon in the trees and the soil, and they produce clean oxygen. So we at the county, as part of our 2040 general plan, have committed to planting 2 million trees in the next 20 years. It's a challenge which is going to be difficult, but it's one that I'm excited to be part of, and one that I'm excited to see completed. Trees provide so much to our community, and besides the obvious benefits, at the end of the day, trees are beautiful, and they create beautiful communities, which we all want to live in. And so when it comes to urban forestry, when it comes to agriculture, there's so much we could be doing to increase the number of trees, make sure we're planting the right trees, and making sure we're taking care of the trees that we have. And so these are all issues and areas which you're going to learn about over the next 3 sessions. And I really invite everyone to dig in and to be part of the solution. I know we at the county are. Me personally, as county supervisor, it's something I'm absolutely committed to. And I ask and I look forward to you joining me in this fight. So thank you and enjoy the series.
Wow. We want to thank Matt Levere for these opening remarks. He is currently in a Board of Supervisors meeting. That's why we had to make a recording. But we're excited for his support as well. So our next speaker will be Dr. Karen Hole. She's Professor of Environmental Studies at UC Santa Cruz, and we're very lucky to have her and have her willing to speak from where she's doing her field work in Brazil. So Karen, please go ahead.
So thanks a lot for having me today. And as Annemiek mentioned, I am currently in Brazil, and I do work a lot globally. I know a lot of the other presentations that are going to be, I also work in California, but in California, I actually work more on grassland restoration. But so I will be talking more globally, whereas I think a lot of the other topics will be focused more regionally. I'll be talking about improving outcomes of tree growing and forest restoration campaigns. And this is work that's done a lot with my collaborator here at the University of Sao Paulo in Brazil, Pedro Roncalleon, my postdoc Spencer Schubert, and a number of other people. Also, it is 4 hours later here and I'm at my Airbnb. So if you hear a little bit of traffic noise, my apologies. Go in here. Okay, so there are many forest restoration and tree planting campaigns. The Bond Challenge aims to restore 350 million hectares of forest globally by 2030. That's an area the size of India. We're currently in the UN Decade on Ecosystem Restoration. There's also a lot of regional goals, such as the 30 by 30 initiative in California, which is partly about conservation, but also includes some restoration. There are at least 3 trillion tree planting campaigns worldwide, one by the World Economic Forum, Plant for the Planet, and then another one by a group of nonprofit organizations. And it's pretty hard to go on your computer without getting a click to donate to plant trees. So one of the big questions is, why is this obsession with trees? Well, trees can have many benefits. Tree planting can have many benefits if well planned. It can enhance carbon and water storage, as the supervisor just told us, can also increase landscape connectivity and native biodiversity, could potentially engage stakeholders through like urban tree plantings. And there is a lot of tree planting groups claim to enhance the local livelihoods of peoples, particularly in the global south. However, there are potential negative effects if tree planting is not done well. If there's extensive tree planting in arid areas, sometimes that has been shown to actually reduce water yield. There's also a lot of concerns about people planting trees into native grasslands, and through that actually destroying a really important and very threatened, particularly in California, native habitat. Also, if it isn't done thoughtfully, it can cause social conflicts. And one of the worst possibilities is that if you actually plant into productive lands and then displace farmers, they may actually move to farm other lands and then clear forest elsewhere. In addition, there's a lot of examples of failed tree planting projects. So in some cases, these failures are due to poor choice of species or maintenance that's done. In other cases, some really sort of egregious cases, there have actually been major social conflicts that have started because these tree planting programs were top down, usually led by groups in the global north, and then for countries in the global south, where the locals weren't as supportive of those efforts. And there's also just examples where there have been programs in place and they really don't seem to be working. Forrest Fleischman, who's at the University of Minnesota in his group, looked at long-term tree planting programs in India and found that they really didn't have the desired effects. In 2019, Ethiopia garnered a lot of public, they got a lot of media because they set a Guinness Book of World Record for planting over 350 million trees in a day. But in the last couple of years, I had an undergraduate student, Thaddeus Mama, who is of Ethiopian heritage, and he did his senior thesis and actually went over to Ethiopia and talked to the government officials about where those trees had been planted. In a lot of cases, they didn't know where they had been planted. They usually hadn't been monitored. And in some cases, they were just planting trees in the same place year after year and counting them as more trees planted, even though they weren't surviving. So my point here is not to say that tree planting is bad. I'm a restoration ecologist by training. I think tree planting is a good thing. But my goal in being engaged in this conversation, which I have been heavily in the last 5 years, is to change the narrative from tree planting to tree growing. And the reason I like to use the term tree growing is, first of all, that a lot of these initiatives focus on how many trees we are going to plant, such as like 2 million in Ventura County. But what we really need to think about is how many trees survive, because you can plant a tree and that doesn't necessarily mean that it's going to survive. The other issue is that you can actually grow trees without planting them. And we can see that in a lot of places where forests regenerate after their own. In Santa Cruz, after post-fire, we see that trees resprout. And so what we're really focusing on is getting a healthy forest or trees out there, 10 years from now, 20 years from now into the future. It's not just about planting trees. So in the last 4 years, I've talked to probably 40 different media outlets about tree planting, and there's a few key points to understand. First of all, tree growing and other natural climate solutions like wetland restoration, peatland restoration, or better agricultural management are not a substitute for reducing greenhouse gas emissions. This is a figure from One Earth, and what we really need to do if we're going to bring our greenhouse gas emissions into balance is we need to have a substantial drop in our greenhouse gas emissions very rapidly. And that is the key. We know that land restoration can take up some of that carbon. And so it is definitely one piece of the puzzle, but we have to be doing this all at once. We aren't going to plant our way out of climate change. The other issue about using trees and just generally natural climate solutions, you can't substitute for greenhouse gas emissions, is because when we are emitting, greenhouse gases and burning carbon, we are emitting geologic carbon, and that's carbon that's been stored very stable in the earth for millions of years. We're putting it into trees, which, as we know very well in California, are not very permanent. They are subject to climate stress. They can wildflower, and also biotic agents like beetle outbreaks. And so this is a map from Bill Andrade at University of Utah, looking at where the trees are likely to be most at risk. But we really need to not look at trees as the whole solution. The second thing that's really key to know about trees is that the first priority should be to reduce the drivers of deforestation and protecting existing forests and existing habitats, which will have immediate and larger climate benefits and co-benefits than tree planting. I'm a restoration ecologist. I've spent the last 30 years of my career trying to help improve restoration. So I obviously think it's valuable, but I will be the first one to say that, just like Humpty Dumpty, it's a lot easier to not break things in the first place than to try to put them back together again. And we also, there's that lag time that when we have forests that are here now, they are conserving biodiversity, they are conserving carbon. So it's not a substitute. And the third main point is that we need to do tree planting right. And so we really need to follow the best practices for tree growing. Because of the many well-publicized tree growing failures in the last few years, there are a number of best practices guides that have come out. There's the 10 golden rules, which was put out by a number of scientists. My collaborator Pedro and I had another one. There's quite a few different ones. But the big question is, are these many guides being followed? The other question I get asked a lot, and as I mentioned, in the last 4 years, I've talked to a lot of high-profile media outlets, National Geographic, Wall Street Journal, New York Times, The Guardian, and I've also advised a lot of different groups on that are both in the non-governmental and the private sector on how to choose projects. And the question that I get over and over again is, which tree growing programs should we support? So this led my collaborator, Pedro Brancaleon, and myself to write a paper in 2022. And that was actually the title of the paper, which is, which of the plethora of tree growing projects should we support? And in that, and then this paper was actually featured as part of the May 2023 National Geographic issue that focused on forests. And 2022. And so what I want to do is sort of slowly walk through the key questions that we laid out, because it helps to think about what we need to be doing to be successful in tree growing. So the first quick question is, what do you hope to achieve by growing trees? And do the proposed tree growing strategies match those goals? So it's important to know that people grow trees for different reasons. A big focus these days is to sequester carbon. There's a lot of discussion up where I live in Santa Cruz about preventing erosions and accelerating recovery after forest fires. Also, a lot of people are interested in conserving biodiversity. Our next talk, we'll be talking about urban restoration, providing shade and increasing green spaces in cities. Sometimes in an area like where I'm in Brazil right now, it's practicing agroforestry, so you provide income, earning money from timber and wood pulp, and many more. So there's a lot of different goals. There was a really good paper a couple of years ago by Meredith Martin, and what she found was that the vast majority of tree planting is for very utilitarian reasons. It's to produce timber, and it's to produce fruits and things like that, and much less so than biodiversity and carbon, though there's more focus on carbon. These are all valuable reasons to plant trees, and I'm not judging one over the other, but there are trade-offs in those goals. The way you do tree planting and what you prioritize depends on what your primary goal is. So to give an example for that, I'm going to use the example of Brazil. Brazil has been in the news. There was a New York Times article last week about how they're trying to get farmers to start growing carbon in the Amazon, in pastures in the Amazon. Microsoft just 3 days ago agreed to restore 16,000 hectares, put up funding to restore 16,000 hectares of forest in Brazil, which is one of the reasons I'm here is working with my colleague who does a lot of advising on this. But just to kind of look at these trade-offs. So Brazil is sort of gotten into the tree growing and forest restoration for a number of different reasons. So some of the funding that they get comes, or some of the motivation is they're part of the Paris Climate Agreement and focusing on their national determined contributions and carbon sequestration. Other funding comes from organizations that also really like the Nature Conservancy, Conservation International, that value biodiversity. At the sort of national and sort of local level, there is a federal Brazilian forest law, and that's really focused on planting along waterways to improve water quality. But the people who are actually often doing the reforestation are farmers who need to provide food, and they're interested in food and firewood and income. And so there may be species that grow really quickly, like eucalyptus, that sequester carbon, but they really don't conserve that much biodiversity. And farmers are probably going to prioritize things like fruit trees or timber trees, as opposed to some of the rarer species that would conserve biodiversity. And again, I'm not making a judgment here on which one's the right reason to do it. It's just that how you do plant trees is very different depending on what your goal is. One of the ways they've done it here in Brazil is they have the Atlantic Forest Pact, which is a group of organizations that really work together. It's about 270 organizations, and they've been working a lot on prioritizations to try to balance some of these different goals. So the next question is sort of how do you do tree planting? And in fact, whether you plant trees. So we know that one of the most cost-effective and ecologically sound methods of growing trees is to actually let nature take its course. A lot of animals, particularly here in the tropics, are dispersed by bats and birds. There's also wind dispersed. And we know that in some cases, forests can recover really quickly. This is a picture in the Yucatan Peninsula, Mexico, of a 3-year-old former agricultural land where in 3 years it actually recovered. Quite a bit. We know after the fires in Santa Cruz that, without really planting that much, redwoods resprout. And so they're coming back afterwards. So probably a better investment of sort of restoration funding, I argue with the local land managers in Santa Cruz, is removing some of the invasive species and not necessarily planting trees. But there is a continuum of tree growing approaches. So as I said, in some cases, natural regeneration may work really well. In other cases, people use what's called assisted natural regeneration, which means sort of looking at, in this case, this is an example from Latin America where they're clearing around the naturally establishing seedlings to help them. This is actually another picture from a burn in Santa Cruz area where, it's regenerating in some areas. This is more shrubland, but you might want to plant in some of the areas that don't regenerate as quickly. The most common restoration strategy, particularly where I work in the Latin American tropics, is planting mixed native species of trees. There's also, as I said, examples of agroforestry, of planting fruit trees, monoculture tree plantations. Now, they're not great for biodiversity, but they do sequester carbon and they work well for timber. And so if that's your goal, that might make the most sense. So the goal here is my point here is that there's a lot of different ways to grow trees. The most appropriate strategy depends on the local ecological conditions and also the social conditions and the project goals. And so those have to be really clearly specified. Next sort of questions that have to be answered are how are local stakeholders involved in the project and what benefits will they receive? Because for us to get the benefits we want from tree growing, it means that trees need to live for decades, for decades. And to do that, local people have to be engaged. And so particularly if there are farmers that are going to earn their income off the land, then we need to make sure that they are involved in the decision-making and actually benefit from the projects. The next question is, have the drivers of deforestation been resolved? Because if we haven't cleared up what caused the issues in the first place, then the trees are just going to be cleared. In a lot of the tropics, where a lot of the focus is on tree planting because they do grow quickly and because they generally have really positive greenhouse gas or climate cooling effects. We have, one of the biggest reasons for clearing land has been, beef for cattle pasture. Also, there's been a lot of expansion of soil and oil palm, which is a way as consumers that we can really think about. One of the best things you can do for conserving forests and reforestation is to eat lower on the food chain, and in particular to eat less beef, but also thinking about like whether the soy and oil palm, some of there's sort of deforestation certified products, and sort of trying to use ones that are more sustainable. Also thinking about, where wood products are sourced. One other point of deforestation, not wide scale, but has been a concern, is that in some cases, if incentives for reforestation are not well designed, they can actually cause deforestation. And there was a pretty well publicized case in Mexico where they had a tree planting program where they paid farmers to plant trees. So the farmers just cleared the forest and then replanted the trees because the incentive system wasn't set up well. And this is where thinking about, what the incentives are for tree planting and making sure that forest protection is first is really important. So, why am I so concerned about sort of like drivers of deforestation? And I'll talk a little bit more about forest permanence. Well, the reason for that is because this is a map sort of showing from 2015 to 2020, where the red areas are areas that are continuing to lose forest, and blue it's increasing. And there are some areas that are increasing in forest, but for the most part, despite all these reforestation efforts, we are still losing forest. And part of that is because a lot of forest starts to regrow and then it gets re-cleared. And we know from Costa Rica, then at the Latin American scale and globally, that there's a lot of forest that gets re-cleared. And so that means that we really need to engage the stakeholders and find win-win situations to be able to do reforestation. And one of those examples is work, it's used widely in Colombia, but some other Latin American countries, such as silvopastoral systems. And what silvopastoral systems are there systems in which they do cattle grazing, but you intercrop them with, you plant trees in the landscape. And so you're actually, by doing that, you actually improve the quality of these are mostly dairy cows, of the milk. And then also you help to forward conservation, but it's a way of conserving, and regrowing forests, and also providing for farmer livelihoods. So the idea here is that if you have an area of land where you plant trees in the productive area, and you can help increase the habitat value here by at least having some tree cover and increasing production, then hopefully you can remove some of the less productive and steep slopes out of production here. And my former PhD student, Elisa Kai, found that actually giving farmers payments to transition helped to increase forest cover in those cases. And so I don't want to go into a lot of detail here, but the idea is coming up with win-win situations where both people benefit and you increase tree cover in an effort to actually increase permanence. So another concern about tree planting that needs to be think about is minimizing negative consequences. As I said before, not planting into grasslands, not planting too much in arid areas. There's really well documented cases. This is in China where they've afforested. They've actually planted trees in areas that didn't have trees before in such large areas that they've reduced water supply. And the other concern that's been getting a lot of press too is affecting albedo. And what albedo is the reflectivity of the Earth's surfaces. And so when sunlight comes down, if it's really light, then the light gets reflected. If it's dark, then it absorbs it. So what happens if you plant a lot of trees in northerly climes, like in northern Canada, where it would normally not have a lot of trees and there's snow, you actually can increase the temperature because those trees are going to absorb more heat. And so you really have to think about the albedo effects. One of the reasons people focus a lot on reforestation in the tropics is because those are landscapes that are naturally dark. So you're not changing the albedo when you reforest them. So Some of the other things to think about, as I really emphasize, is the importance of maintaining and supporting projects after the first few years, not just planting the trees, but making sure they grow, and then monitoring outcomes over time to make sure that you're actually achieving what you want, and then using that to guide adaptive management. And so it is really important to plan for permanence, as I keep emphasizing. It's the quality, not just the quantity of reforestation. So I really think we need to be moving beyond the let's plant 1 trillion trees to maybe let's have 200 billion trees that are alive in 10 years. And so really focusing on farther out time periods. Selecting species that are likely to survive in future climate conditions, providing funding over longer terms, not just to plant the trees, which is what a lot of groups do, and also thinking about selecting lands that are less productive for agricultural uses for reforestation, because those are much more likely to actually persist over time. And just as an example, this is a paper from Susan Cook-Patton and colleagues at the Nature Conservancy, and they looked at they were trying to figure out places you could plant in the United States that would be most likely to have longevity. So what they did was they looked at areas like where this is, where it would make the most sense. So maybe in protected areas that don't have a lot, that are were forested and aren't as forested, post-burn landscapes, pasture lands in the Southeast are a big focus because were not necessarily always grasslands. And so it's an area, they're not particularly productive. Places where they flood a lot, or they're challenging soil conditions, or urban open spaces. And then they went out and they interviewed practitioners to kind of identify areas that would work. And this also shows that where you might plant in different areas of the US that show the most promise vary quite a bit, but really trying to think about places that aren't going to heavily compete with other land uses. So, and then finally, as part of this paper that we wrote, we sort of talked a little bit about the funding landscape for reforestation. And so some people plant trees on their own land, which is great, but in most cases, people are providing funding for other people to grow on their lands. And sometimes those are private, sometimes those are public funds. And what we found in the landscape is what we call intermediary organizations and implementing organizations. Implementing organizations are those groups that are actually growing the trees and are doing the projects on the ground. There's also quite a few organizations, like often usually in the global north, things like Plant for the Planet, the Nature Conservancy, Conservation International, that are more intermediary organizations. They raise funds and then they give those funding, to actually do projects on the ground. So important question to ask is, what are the outcomes of these organizations in the past? And also, how will the funding be allocated across organizational scales? Because, is a lot of the money going to these intermediary organizations, or is it actually going to implementing projects on the ground? So the last phase of my talk here, I'll talk about sort of a recent study where we actually went out and just tried to answer these questions. So between January and March of 2023, we evaluated in my lab, this is largely led by my postdoc Spencer Schubert and a number of students at UCSC, how well 99 different intermediary organizations, so there's a lot of these groups out there, there are hundreds or thousands of implementing organizations globally, how well they share information publicly about how well they follow these best practices guidelines. And we had a minimum of 2 reviewers of their websites, and we also developed a best practices index to evaluate how well they were meeting the guidelines. And obviously there's a bit of, there's a little bit of a flaw in this because we're mostly looking at what they publicly say as opposed to interviewing every organization. But we feel like if funders are trying to understand better, what they're doing, then it's incumbent upon these organizations to let people know how well they're following best practices. So what did we find? We found that about 90% of these intermediate organizations were in high-income countries. About 2/3 were nonprofit, and 1/3 were for-profit. Though I'd say that there are more and more for-profit companies. About 65% of the organizations were started in the past 25 years. They range a lot in like how many trees they've planted, staff size, and also the scientific qualifications. We developed this index to sort of look at, how well they were following best practices. We found that nonprofits, organizations, and organizations with more past experience and scientific expertise, not surprisingly, provided more information on following best practices. and they had clear criteria for selecting projects to fund on the ground. We found, as was sort of what I told you earlier, that on average, different groups claim to have 5 to 6 goals for tree growing, which is a little bit concerning to me because of the trade-offs I talked about between them. You can't achieve all goals at once. These were sort of the top goals. They said biodiversity conservation, human livelihoods, and carbon sequestration and water. I would say that the evidence suggests otherwise, that in fact, people are doing a lot more for carbon and for things like timber. But this is sort of the stated goals. When we looked at local participation, which is really important, we found that a lot of people were involved in implementing the projects. They involved locals, but not as many in the goal setting and monitoring. And it's really key to involve groups early on so that, you know, they're engaged and are willing to maintain the trees over time. And they claim to have a lot of different benefits for the communities: food security, education, income, ecosystem services. So many groups said that they would engage local communities and give them benefits, but the monitoring of how effective that was somewhat lacking. Most of them talked about how many engagement variables, just like how many people actually participated, but rather than looking at particularly, you know, what the actual benefits are. Did people benefit economically, particularly in lower income countries? When we looked at maintenance, monitoring, and project longevity, only 25% of the projects had measurable time-bound objectives. A lot of them provided information on their monitoring, the protocols they proposed to do, but there were very few data available, and only 41% even reported how many trees survived in their projects. And so this is kind of a complicated figure, so I'll walk through this a little more slowly. This shows the percent of organizations, and this is how long they're committing to projects. So in a lot of cases, it's unclear. In a lot of cases, they also say locals are responsible for continuing, but they don't state how that's going to be funded. If they did state a time commitment, it's usually about 1 to 5 years, and there are very few organizations that are making longer term commitments, and this is concerning. When we looked at funding and whether they actually had their timeline for funding projects, it's very few had long-term commitments, and a lot of them had no information about, you know, what was going to happen for the projects after the trees were planted. So, okay. So about 78% of the organizations recognized specific drivers, and most of those discussed how they're addressing them. And 19% discussed potential negative effects of reforestation, the most common of which was the problem of planting exotic species, invasive species that then spread. So they had ruled out using such species. And only a third of the organizations actually displayed their cost split between the intermediary organizations and local organizations. On average, about 80% went to local projects, but there's a huge range. So it's a good thing to think about when you're donating, like what percentage of the funding is actually going to on the ground projects. So sort of guidance that we have for organizations. First of all, it's really important to establish clear criteria for selecting local implementing organizations and projects that follow best practices, and thinking about things like community engagement and land tenure, and, you know, who's going to maintain over long term. Making longer term commitments to maintenance, funding, and monitoring. And also it's important to provide to potential funders a split, you know, more information about what the outcomes of projects are and what the funding split is. If you're thinking about what organizations to support, in general, more experienced organizations follow best practices guidelines more closely. I recommend looking for concrete details about, you know, what their outcomes are, as opposed to like flashy videos or just the number of trees planted. And I would also look at where your money is going. You know, is it going to on the ground projects, or is it going more towards just overhead in administration in the intermediary organizations? So sort of where are we headed next? Well, in general, I'm doing a lot here in Brazil right now is I do a lot of research on how to do tropical forest restoration, and also helping to provide guidance on some of these big projects that are being implemented right now and developing strategies to do restoration at scale. But next steps for this particular research about these tree growing organizations, one of the limitations with our data to date was we looked at publicly available information. We're hoping to get some funding, but it's still uncertain. So we're still looking for funding to do this, to follow up directly with organizations to get a better sense of what they're doing. What we really want to do is actually map tree cover changes for projects. And so sort of look at, where groups have said they actually are restoring forest, and then looking at, does the remotely sensed data suggest forest cover has actually increased? And then looking at, if you do use best practices, how does that, is that linked to these sort of more successful outcomes happening? So with that, I will stop and say that I'm happy to answer any questions. This is a link to my webpage. And so if you want to know more, and some of the more general audience publications are there, you can look that up. A bunch of this research has been funded by the endowed chair that I hold from the MacArthur Foundation, so I'm grateful for that. And with that, I'll say thanks for listening, and I will be happy to answer any questions. So I think I will stop screen sharing so that people, or maybe I'll leave it up there just for a minute. So thanks. I don't know how I think you're going to read me the questions. Is that correct?
Correct. And I just wanted to thank you so much for this global perspective. I think it's very helpful to also have a very realistic view of what this reforestation all means and how it's done. So I guess, Maria, do you want to read the questions?
Yes. So far I only see one. How does grassland compare to forest in their ability to draw down carbon from the atmosphere?
So the forests generally sequester quite a bit more than grasslands, because you sequester a lot above and below ground. Grasslands do have some ability, and most people focus more on grasslands as far as like in the soils. And actually, as I mentioned, I do work on grasslands in California, and we actually have a grant right now in the Santa Cruz area. One of my grad students and I are working on a project where we're looking at the effects of controlled burning on and whether that, if you're using controlled burning as a land management tool to prevent spread of fire, like in the forest, how does that affect soil carbon? And so we'll be able to answer that question again better in about a year or two. The most productive ecosystems, wetland ecosystems, are also really productive. Things like peatlands and salt marshes, because they store an enormous amount below ground. They often also provide coastal protection. One of the most productive systems are mangroves, which are tropical coastal wetlands, because they have a lot of above ground biomass and a lot of below ground biomass. And so it's kind of hard to say like different types of forests sequester different amounts of carbon, same with grasslands, but in general, forests sequester a considerably higher amount of grasslands. Higher amount of carbon than grasslands. Some people do argue that some of the grasslands, because the carbon in grasslands is stored in the soil, that it's tends to be a little bit more resistant to like fire, and obviously it's not going to get cut down, so it's not as much, it's a little more secure than above ground. So that's kind of some of the trade-offs there. Were there any other questions in the chat?
Yes, you have one in the chat. It is, what is your impressing of the microforest Miyazaki method?
Okay, the Miyazaki method. The thing about the Miyazaki method is, it does seem to work, and I think it's probably most appropriate in urban environments. It uses, for those people who don't know, it's a very dense tree planting method that was, and I'm not super knowledgeable on it, so I'm kind of at the edge of my knowledge here, but I believe was developed in Japan. But when I have read about it, the density of tree planting in those cases is not really, in my opinion, going to be scalable at scale. And so one of the things I've been thinking a lot about with my colleague in Brazil here is, if they're trying to do like thousands of hectares, and for those of you guys who don't think in metric, a hectare is about 2.5 acres. So something like a 16,000 hectare project, or let's say there's a number of like 5,000 hectare projects. That's like 12,000 acres of reforestation. So you really have to be thinking about what is scalable, and what's it going to cost? Also, how are you going to get the seedlings and seed supply? Because one of the biggest challenges to reforestation now in the United States or globally is not having enough seeds and seedlings, because, you know, we have this, you got to scale the nursery production up. And one thing that happens is it takes some time to do that. And there was actually a really good report last year that came out of the National Academy of Sciences looking at, you know, what would need to be done to really scale up our seed and seedling supply. And we really need to be providing some sort of supports to those groups so that they don't, like, one year get asked for like 1 million seedlings and the next year for like 2,000 seedlings. And so kind of the way we do with farmers, that you're really helping them to build the infrastructure and provide a demand, more stable demand. So sorry, I went off on a tangent there. But the thing is, I think the Miyazaki method, gosh, make sure I spell it. That method it's obviously been proven to be pretty useful in some urban areas, but I just have some questions about really thinking about how you can plant at scale, because you can't plant that densely.
We have a few questions in the Q&A. One of them being, what do you think about CAL FIRE's approach to native habitat management?
Ooh. That's a pretty broad question, and I think I would be going out on a limb and saying, I don't know everything that CAL FIRE is doing. There is a big focus in California now on trying to do understory thinning and mastication. And I mean, I'm familiar with some of the different management methods that they're using, at least I'm mostly familiar in the Santa Cruz area where I work. And you know, there is a big focus on trying to look at what the most cost-effective and environmentally, you know, beneficial methods are, where you both reduce fire risk and also try to, you know, create a more open habitat, because, you know, our California forests are fire adapted, but there's concern because of the really intensive fires. And so beyond that, there's a lot of good stuff going on in California right now, not of sort of trying to get prescribed burn associations and trying to get more people involved in burning and more people involved in forest management. But I can't talk about everything the CAL FIRE is doing. So, okay, cap and trade policies on climate change. Well, they're problematic because I mean, we need to be reducing greenhouse gas emissions. And so I really personally think that a carbon tax would be a good thing. But we really need to put a price on carbon, and we need to acknowledge the costs. Some of the cap and trade stuff and some of these sort of offsets, the offset markets in California have been shown to be really problematic because they aren't being monitored well. And so we really need to make sure that if we are doing offsets, I mean, that we need to be reducing greenhouse gas emissions is first and foremost. But if we are going to be doing offsets, and now people are going to biodiversity offsets, we need to make sure that they're legitimate. And so far, there's been a lot of critiques, and there was a really good expose last year on a bunch of the Vera projects in California that really aren't achieving what they said they're going to achieve. But I don't work personally in the carbon markets that much. Okay, could you please talk about the diversity of species and the benefits versus monoculture, also the age of the forest? So again, how many species? Planting a more diverse set of species is really helpful. Is helpful because you don't have as much risk, because you have different species there and you aren't as likely to have pest outbreaks, and you know, the more like there's species that can resist climate stress. And oftentimes you have species that grow at different rates and that provide different functions like nitrogen fixation. And so that's really helpful. So if you're planting for biodiversity, you probably really want to plant more species. A lot of the projects here in Brazil plant like 50 or 60 species. And so, I mean, there's like 1,000 species in the forest. There's a lot more species. So that's really helpful. If you're planting for timber, one of the issues is that most of the timber markets are, they're scaled to like, there's certain species that we really develop the markets for, and everything's developed to that. And so if it's just straight timber production, there is a role for things like pine plantations in Southeast United States and for eucalyptus plantations for paper pulp here. The question is, you know, like, so again, it gets back to what your goal of the project is. Also thinking about, you know, in some cases, maybe trying to develop more native timber species, but you can't just all of a sudden start marketing rare timber species if that's your goal. As far as carbon sequestration, you can sequester a lot of carbon in monocultures. You can also sequester a lot of carbon in native species. So if you want to get biodiversity met and carbon, then you need to really require that so that you plant native species and you ask for the carbon in the same place. Otherwise, people can start doing things like growing eucalyptus plantations. And I can tell you, because there's a lot of them here in Brazil, eucalyptus plantations grow really fast. I mean, really fast. And so you get a lot of carbon there. So you know, it's sort of, again, a balancing and saying, okay, if my two goals are biodiversity and carbon, then I need to do that with a diverse suite of species, but also picking native species that grow quickly enough.
Okay, Karen, we
Um,
have time for maybe one more question.
Okay.
But
Somebody has here this one about how can we scale up tree production in light of the consolidation of the nursery industry. And I would, again, if you look at like, I might be able to find it here, the National Academy of Sciences, seed supply, look at that, I looked it up the other day. I would say that this, I'm gonna put a little note in the chat here. This is a great resource if you're really into the weeds and want to know more about that question. And I think then actually, now I gotta find the chat here. Well, I'll put it in the chat when the next speaker comes up. Okay, oh, here's one of my favorite questions. I'm gonna answer this one. The $2 per tree. Well, that's great, $2. That's better than $1. Here's my story on the $1 a tree. You might be able to plant a tree for $1. You can't grow a tree for $1. I mean, it also depends where you're planting, because obviously there's different prices. Like an urban tree in San Francisco is going to cost different than a tree in, you know, a farm in Africa. But the point is, so I really think this $1 tree thing does bother me. We really need to think about not just how much does it cost to plant the tree, but how much does it cost to also compensate the farmer? How much does it compensate to keep the trees growing over time? And so going for the absolute cheapest trees is probably not always the best bet. But we really need to think about tree longevity and getting what we're actually achieving the goals that were the aim of the project. And I think that's a good place to finish and pass it on to the next speaker. So thanks everybody for all these questions. And I'm out of time. So
Thank you so very much. That was very enlightening. And I guess we're going from global to more local in looking at the huge metropolitan area of Los Angeles. Our next speaker is Dr. Edith de Guzman. She is a UCA&R Cooperative Extension Specialist in Water Equity and Adaptation Policy at UCLA. And she's going to talk about climate resilience through urban greening. Go ahead, Edith.
Thank you very much. That was an absolutely fascinating presentation. Mine will be quite a bit different. Perfect. Well, thank you very much for inviting me. We are indeed going to zoom in and change topics somewhat, but still talk about the role of trees and what it all means for us in an urban context as the planet warms. I thought I'd start with just a tad about myself. So I have quite a connection to UCLA, which is where I now am, sort of starting on the right there. I'm the first cooperative extension specialist at UCLA. But I spent nearly 2 decades in nonprofit at a nonprofit organization called Tree People. During that time, I completed my bachelor's, master's, and most recently my PhD at UCLA. I took a good long break between my master's and my PhD, and I'm so pleased to now be at UCLA as a cooperative extension specialist at the Luskin Center for Innovation, where in addition to working on the topics that you'll hear about today, which pertain to urban forest equity, heat mitigation, and how those two things are linked, I'm also working on water issues. But without further ado, let's start with thinking about the first of those topics around heat mitigation and how urban forest equity fits in. So I'm going to organize my talk around a few questions, and this is going to be somewhat interactive. So I will be inviting you all to answer some poll questions. So my first question to you is going to be around how amenities, the first question that I'm sort of organizing around this is how amenities that are available for people in the urban context, how are those availabilities different by neighborhood? And so before I ask you to answer that in a poll, let me give you a little bit of an overview of how things sort of present themselves in Los Angeles. And so going back about 3 years, National Geographic, as their cover story, featured Vermont Avenue in Los Angeles. And the story they were trying to tell was around how urban forest distribution is vastly different. And they looked at just along one stretch of the street from the northern portion to the southern portion. And you can see this is a sort of a spatial, imagery that you can see along that. We start with these majestic, large trees and end up in the southern part of the city with virtually none. And this correlates to some policy decisions that were made in the 20th century, which we will explore. So if we look at this from the perspective of what it looks like in the air, you can see two neighborhoods in Los Angeles. Brentwood on the right is predominantly affluent and predominantly Caucasian, and on the left is a low-income community, Boyle Heights, that is predominantly lower income, as I mentioned, and predominantly people of color live in this community. What's interesting here is you can see that the urban forest cover is drastically different. What's not different is the size of the houses. So, Boyle Heights is this historic community, and there are some rather large and majestic homes, but the amenities from the perspective of shade and urban forest cover obviously differ quite a bit. When we think about this topic of exposure to heat and what amenities are available, the human context really matters. And here I'm sharing an image of one of a student team that we had a few years back from the UCLA Environmental Science Department. We had groups of students essentially characterizing the pedestrian experience of heat in 3 different neighborhoods. So here they are in a neighborhood in the Northeast San Fernando Valley of Los Angeles with a high of 103 degrees on this particular day. And what you can see is that from the surface temperature perspective, there are vast differences within just a few feet. So you can see that the concrete bench and the sidewalk are up to 50 degrees and upward of 50 degrees hotter in surface temperature than the shade of this rather poorly pruned ficus tree is offering. And what you can see is that our student is sitting on this bench looking rather uncomfortable, but the wiser transit, folks that are waiting for the bus to stop near that student are actually enjoying the shade of the tree. And this, of course, has implications for the ambient temperature or air temperature that we experience. Continuing on the human context here, we happened to capture the hottest day in LA County's history during a study that we conducted over a few months. That was looking at what the impacts of the presence of trees versus the absence of trees is in the residential context. So in various residential sites around Los Angeles, we had community scientists that were hosting a thermal network, thermal sensor network. And what we found on this day when it hit 121 degrees in the western part of the San Fernando Valley and Los Angeles County, in the southern part, what we found is that an indoor site that had no trees, has no air conditioning, hit 170 degrees indoors. This is in a living room. Now, you could be an Olympic athlete, but if you are exposed long-term, and by long-term, I mean just within a few hours, to these kinds of temperatures, you are very likely to experience some kind of heat-related illness and potentially end up succumbing to that. So as I promised, this is going to be interactive. So you can either scan this QR code on your phone, or you can go to the link at the on this slide. So menti.com, and then put in the number 94274830. And the question I'm asking is, why do some neighborhoods have more tree cover and others have less? So let me now navigate over to that. And let's see, so far, hopefully you can still see this. Well, somebody put in the code there, but what we want you to put in is why some neighborhoods have more tree cover and others have less. And so we've got some answers, and the way that these word clouds work, the larger the word becomes, the more times it's been repeated. So if you see something that's coming up on the screen that you agree with, you can put that in, and that will become a larger word. So you can see that wealth, money, availability of funding, income difference are all coming up. Redlining and urban planning, disinvestment, poverty, structural racism, yard size, sure. So these are all exactly, correct. Availability of water is also important. So, and there are also ecological reasons. Some parts of Los Angeles or other parts of California or the world, there are ecological reasons why there might be more or less cover, but great, that's wonderful. So thank you all for participating in that first poll. Keep that open because I'll have another few questions for you. So as some of you pointed out already, indeed, redlining is one of the causes for these inequities. And here you can see 3 of the maps that were produced in the middle of the 20th century, starting in about the 1930s through 1968. And this was a process by which the federal government graded neighborhoods by desirability. And so the redlined communities are those that were deemed least desirable and consequently received less investment, less availability of mortgage lending, insurance, and other types of services that would have provided more investment in those communities. And what we know nowadays is that even though this is a practice that became illegal back in 1968, so it's been more than a half a century, presently the outcomes with regard to social vulnerability are very much still linked. So what you see here on the left is one of these original maps, the redlining maps for Los Angeles. And on the right, you see present day social vulnerability metrics. And you can see that by and large, the red and yellow areas are still those that experience these more sort of extreme inequities with regard to a variety of different factors that look at social vulnerability, economics being one of them. Diving in just a tiny bit more here, I was curious about the neighborhood where I live. So this reddish area here is where I live, and the sort of white area, I don't know if you can see my cursor or not, UCLA is located right there, just kind of northeast of where I live. And I was pretty appalled to see what the kind of language that was used, continued infiltration of subversive foreign elements. So we know that we're still fighting the outcomes of these kinds of decisions, and that it's a history that we're not very proud of in this country. So what we also know is that there are very tangible outcomes, not only with regard to tree distribution, which we'll explore in just a moment, but also in pertaining to the exposure to heat that is experienced differently in neighborhoods that are in the same city. And so This is a paper that was published back in 2020 that asked the question of how do these historically redlined neighborhoods currently relate to patterns of heat? And what was found is that in each of these, 4 quadrants of the country, there are still measurable impacts and differences that link to these historic decisions. And so you can see on the in the West, where we're located, there is a much larger there's a higher likelihood that you live in a well-forested urban neighborhood if you are in one of the A or green areas than if you are in one of the redlined areas. And this is true throughout the country, with generally a 2 to 3 time sort of ratio that can be expected between those things. But the inverse is true with regard to temperature. And so looking at the same cities, this is not comparing neighborhoods across different cities. This is really comparing neighborhoods within one, the same city. The differences with regard to between redlined and non-redlined neighborhoods of experiencing the same heat event, the same heat wave, are pretty stark. And so there are certainly links to tree cover that result in these outcomes. And what the researchers found is that on average, it was about a 5-degree difference if you were in a redlined versus non-redlined neighborhood. So it'd be 5 degrees warmer, but it could be up to almost 13 degrees Fahrenheit warmer. So we're talking about pretty pronounced differences. So now that we know a little bit about these inequities and understand that there's a link between heat exposure and tree distribution, the question is, well, where should we plant in order to maximize benefits and address these inequities? And so I was surprised to find out a few years back, I was, writing to all of the various GIS officers in the county and in the city of Los Angeles and universities, and nobody seemed to have a sort of granular way of understanding which parcels or zip codes or census tracts or cities within the county had, what the tree canopy cover was. So with funding from the Forest Service and CAL FIRE, we were able to make a tree viewer that was LiDAR based. And this was quickly, the process was essentially looking at getting this aerial imagery that through these processes of deriving the most granular data, including not only tree canopy, but also other types of land cover, so buildings and roads, et cetera. We were able to then extract what the existing tree canopy is down to the parcel level, and also what the possible tree canopy might be. So that would be the amount of land that's not covered by trees, where it could potentially be feasible to establish new tree canopy. Although I should say that there's a caveat that, for example, Dodger Stadium, but would appear to be a really good place to plant many trees. Unfortunately, it's not the most ideal place if you love baseball. So what we found is in short, is this. For the city of Los Angeles, the existing tree canopy cover is this is on the top. By and large, the largest proportion of the urban forest that exists in Los Angeles is in residential parcels. The second largest sort of land use that's represented here is recreational, and then rights of way. So that would be streets and medians and the like. So what this means is that with anything that we want to do in terms of either preserving or augmenting the canopy, working with residential land and homeowners or property owners of those lands is really critical. We also looked at that potential. So where's the potential for actually growing more tree canopy? It was the same thing for the city of Los Angeles. Not only is the existing tree canopy largest in residential areas by acreage, but also the largest potential for growing additional canopy is in residential areas. This was not the same thing that we found. Did I not have, I guess I took out the county slide, but we found that in the county, residential is still very important, but recreational is actually even a larger proportion. We also took a look at what the relationship is of existing tree cover and the year that the home was built. And what we found is that older homes typically have more tree cover. Now that might seem sort of logical because, older homes have had more time to establish that tree cover and those trees have had more time to mature. But what we see is this kind of steep drop off after, in the 2000s, after about 2000 and 2010 there, you can see these steep drop offs. And the reason there is because there's a real densification that's happening. So not only are we removing trees as we redevelop, but also we are allowing less room. Less of the parcel remains to have impervious land. So we're covering up more of the land and thus creating less space for trees. And we looked at the relationship between tree cover and home sale price. And what we saw here is that the higher the tree cover, the more the expected home sale price. Now, this also seems like it might be somewhat logical, but what we found as we dug into this is that there's actually quite a link to where the home is sold. And so neighborhoods that are wealthier did tend to have those more attractive sale prices given the types of homes and neighborhoods that they were located in. And we looked at by census block group. Each of these polygons here, these rectangles, represent a census block group in the city of Los Angeles. And what this image is telling us is that there are 5 census block groups within which nearly 20% of the tree canopy of Los Angeles, the city of Los Angeles, exists. The reason why you see Brentwood there twice is because there's more than one census block group in Brentwood. So, this is, again, there are some ecological reasons. These happen to all be neighborhoods that are in the hillside communities and rather than sort of more of the flatland areas. But we know that socioeconomics do have a piece of the answer for why that inequity exists. So after we produced these analyses, we also produced a viewer that's available online. You can see it there if you're interested in checking it out. And this enables people to go and explore their parcel, their neighborhood, their zip code, etc., and see how their canopy fares compared to other parts of the county. We also, did this for the other data that I mentioned. It wasn't just for trees, it was also for these other land cover types. So whether you're interested in seeing how much building and other impervious surfaces there are versus spaces that are pervious rather, that's available as well. And this function is probably the one that I got most excited about. This shows where it makes sense to try to plant more. So the ideal places without making too many modifications to the urban environment would be to target those neighborhoods that have presently the lowest existing tree canopy, but have the highest possibility. So that would be neighborhoods that contain a larger preponderance of impervious spaces that are presently unplanted and the like. So with all of that now, the next question that we asked was how, could changes that we make to the urban environment, everybody wants to live in a better shaded space. And we know that heat and trees are heat exposure and trees are linked, but could this actually save lives? And so my colleagues and I co-founded what we call the Los Angeles Urban Cooling Collaborative, which is a very interdisciplinary group that looked at this very question. And it included both nonprofit organizations, academics, and state and local governments that participated with us. And what we elected to do was to test prescriptions, as we like to call them. So we think of Los Angeles, we decided to kind of look at Los Angeles or any city as a patient that is ailing from extreme heat. What would we prescribe to that patient? If we wanted to reduce the temperature of our patient, what would we prescribe? And so the idea for us was to see what the different combinations of increased tree canopy and increased solar reflectance of roofs, pavements, and walls, how would those actually change public health outcomes in terms of number of people that are killed by extreme heat? But before we get to that, how many reduced ER visits we would be able to see? And so I'm going to share the outcomes of that research with you in just a moment. But before we do that, I'd like to invite you to go back to the Menti again and describe what groups are most vulnerable to heat, just in a word or two. Who is most vulnerable to heat? Let me advance the slide here. Don't know why it's not letting me right now, but Okay, here we go. Sorry about that. It was giving me a bit of a problem, but what groups are most vulnerable to heat? You can, if you still have your Menti open, you can use that. And if not, you can use that code at the top there that you can see on the screen. And you're absolutely right. So we have elderly, children, so people at both extremes of age distribution are more susceptible because of their physiology. The unhoused, the immunocompromised, or the ill, including chronically ill, and somebody said here mentally ill, which is correct. These are all risk factors, people who are low income. We have the disabled, those who work outdoors. So that's exactly right. I think you could all give this talk instead of me, I think. I will mention though, you notice that I asked what groups, not necessarily what groups of people. And I would say animals are also vulnerable to heat, and our flora is also vulnerable to heat. So we have to think about how extreme heat is impacting our urban forests and our, whether it's native or adapted vegetation here in our city. So thank you very much for indulging me again, and keep that open, because if we have time, we'll do one more Menti at the end. So what we did in this study, as I mentioned, we thought about these as prescriptions. And so we tested out different dosages of tree cover and that solar reflectance of roofs and pavements and even walls. And we looked at historic data. We looked at actual heat events. We looked at 4 different heat waves that are all sort of emblematic of a certain type of heat wave. So we had the very hot and humid event in 2006 that is still one of the most significant heat waves that California has historically experienced. We looked at a drier type of heat wave. We looked at a more sort of common heat wave just to see how public health outcomes would respond. And then we looked at our notorious Santa Ana events, the very hot and dry events that we're known for in our region. This is what the modeling for the meteorological side of things looked like. So we first applied these various prescriptions to the land and looked at what the meteorology changes would be. And so this is a low tree cover, high reflectance scenario. And the arrows indicate where what the sort of direction of that movement of air looks like. And what we can notice here is that actually in certain cases, while there's a lot of cooling that occurs, blue means cooler, red means hotter, in the middle of the day at 1 p.m., we see quite a positive outcome in terms of cooling, but we see that by 5 p.m., actually some of the heat might have been displaced into some parts of the county. So it's important for us to be aware that sometimes there are unintended consequences while we're trying to do something that improves outcomes. We did this at the county level. We also did this for a handful of what we called districts, though they're not, jurisdictional districts. These are fairly large areas with we needed a certain amount of population for each to see the signals happening in terms of public health outcomes. And what you can see is that when we apply our process, looking at those meteorology outcomes and then apply public health outcomes, actual mortality and ER visits, we see that there is the opportunity to improve those outcomes quite substantially in some of the most vulnerable parts of Los Angeles. And so we saw upwards of 20, 30, 40, even upwards of 50% reduction. In this particular case, this map shows mortality reductions, and that's very significant. Much more recently, actually just a couple of weeks ago, we published a follow-on study that looked at the reductions in ER visits. And what we saw is that in a low tree canopy and solar reflectance scenario, ER visits could be reduced by 5 to 45%. Now, this all depends on the heat wave type and the like. We also saw that when we went more aggressive with a high scenario, we could reduce those ER visits by more than 50%, up to 66%. So that, as I mentioned, we just published, and I'm pleased that Wired magazine actually picked this up and wrote an article about our article. And so that was just published a few days ago. And if you're interested in seeing that, there's the QR code for it. So a summary of those results is that temperature reductions can often exceed 3.5 degrees Fahrenheit. And that doesn't sound like a lot, but it's a life or death difference for some. We saw that reductions in heat-related ER visits and deaths between 25 and 50% were pretty common. It's very much within reach, and this means we could save dozens of lives in the worst heat waves. And we also saw, I didn't go into this, but we saw that there are certain types of oppressive air masses that could we could change meteorology locally to actually create more hospitable outcomes. So, okay, you're hearing here that I'm saying more trees would be good. And how do we get there? How do we get there when there is this obvious inequity that we are still trying to address? And so yet another sort of group that came together was something that we call the LA Urban Forest Equity Collective. And you can see that it's represented by quite a number of different players, again, nonprofit, academic, and government. And what we did with some funding from the US Forest Service in 2020 and 21 was first kind of try to understand assess urban forest inequity in Los Angeles. And one of the outcomes that we produced from that process was to create a tiered planting system. This is a way of considering urban space by its potential for hosting additional canopy. So a tier 1 would be a space that's available. There's no site modification needed. Maybe it's a front yard, maybe it's an empty tree well in a street. A moderate tier 2 would be a site where there is space, but it isn't currently available. In other words, there's a need for a bit of a modification. So that could be maybe a sidewalk that is wide enough, but doesn't presently have a tree well. So you might need to cut out some concrete or asphalt in order to make that space available. We know that if we were to plant both tier 1 and tier 2 spaces, this still would not necessarily create an equitable urban forest in every neighborhood, and that we would thus need tier 3, which are those harder, more drastic site modifications that would be needed, and thus there's more investment that's needed. That was in the first phase of the research that we were able to engage in. And in the second phase, which just concluded, we wanted to look at what's possible, what should we aim for, and then what could we really do from a spatial perspective. And so we developed an evidence-based framework that is very much rooted in what the research suggests can actually be accommodated and improved by trees. I know that we often hear about trees being a very feel-good investment that is thrown on a variety of problems as a potential solution. And we were interested in making sure that from the physical and economic need, the exposure, environmental exposure, et cetera, we actually were able to produce a framework that would enable us to think about which communities would be prioritized, given we live in a world of limited resources. And so what we did with that is produce a web page that policymakers and others could actually explore. And we also built upon that tiered framework that I've initially told you a little bit about. And what we did there is really create a sort of guidebook that allows people to take a look at what the possible investment and ease of implementation and existing sort of availability might look like for their community. So those were just a few examples there. We tested all of this out in 2 communities. We only had funding to do engagement in 2 communities in Los Angeles, and we chose South LA, Central Alameda, and the Sylmar neighborhood of Northeast Los Angeles as spaces that we were going to do engagement in. We conducted surveys. I know I'm going a little bit fast here, but I don't want to take up more time than I'm allotted here. So we engaged via community surveys and workshops and found that the most valued benefits of trees in both communities were beautification, improvement of air quality, and reduction of heat, and that the most desired locations for planting were residential streets and parks. I understood that there are some barriers to planting, including the notion that people think that it's the responsibility of the city to care for trees on the street. And of course, that's something that's hard to argue with. And so here's with some of the engagement after the surveys. We did some workshops and really tried to understand what the desires are in these communities. And we produced these 2 neighborhood strategy documents with some renderings that show some of the potential ideas, both in the easier tier 1 and 2 configurations, as well as the more difficult tier 3 configurations, which you now see on the screen. Part of our process was also doing a deep spatial analysis, understanding really strategically and specifically and granularly what's the total number of trees that could actually be added under this kind of easier tier 1 configuration. And of those, how could we sort of prioritize the largest possible tree for each of the sites? And we produced equity metrics. And the one thing I just want to point out about, these are just a couple of the equity metrics. There are many more that we produced in this sort of measurement of success framework. But the one thing I want to point out is that we looked at various types of equity facets, distributional being one, but also recognitional and procedural, which really look at some of the more nuanced ways in which communities engage with their urban forest and their neighborhoods. are really poised to communities and doing engagement in additional communities outside of those two pilots. The good news is that currently the city and county of Los Angeles are both adopting this in some way into their various management plans that they're working on. And of course, we offer this as hopefully a bit of an inspiration for other regions to not only adopt this kind of thing, but also really improve upon it. And if you'd like to read more about that, I was invited to write a guest blog post for the Union of Concerned Scientists, and all of the reports and various publications that we produced out of this process are linked at that URL. So I think I'll keep it at that. I know that we're probably running out of time now, but I really appreciate everybody's attention, and thank you for inviting me.
Okay, thank you so much, Edith. This is a wonderful presentation, very different from the first one, but I think it really helps us understand the practicalities and what goes into tree plantings. I know we're a little bit limited on time. I know there's quite a few questions. I think what I would suggest is, I don't know what your time is, Edith, but that we could answer a couple, and then those people that need to go can go, and then we can, if you have time, to answer the remaining questions, if that's possible. So I
Sure.
think for now, Maria, do you want to read the questions?
Yes, I have one that is a little hidden. It says CAL FIRE gives grants to cities for street tree planting to increase the tree canopy. Is this a good idea for a long-term solution?
I think it can be a good idea, but I didn't get to talk about this much, but there's this perception by the city residents that it should be the city's responsibility for care for trees. And unfortunately, the reality is that oftentimes, historically, these grant dollars that have flowed to nonprofit organizations in the city will often pay for tree planting, but not tree maintenance. And in our environment, in our climate, that's a problem, because we need establishment care for those trees. And so the burden sometimes falls on the goodwill of residents, and that's not a good thing, because especially when we're thinking about equity, it's the least canopied neighborhoods that have the most burdens in other factors, across other factors that have to bear that. The good news is that the types of funding mechanisms that are now coming through the state offer more funding for maintenance as well. So as long as that maintenance can be offered by crews that are paid, and hey, if they're local crews, all the better. You can ask residents to do it if they're paid and if they're compensated. Then that's great. That's my opinion on sort of the state of those types of funding mechanisms.
Okay, so what I want to do right now is just do a close and then leave some time for the other questions, people, if they can stay around. But I want to thank the speakers for some wonderful presentations, the audience for your attention throughout this. I invite you all to come back tomorrow when we're going to talk about optimizing tree survival at a more practical level. And also want to thank the program support unit for their help. So thank you, and then we'll just continue with the questions for just a little while. So go ahead, Maria.
Next question reads, the cost of residential water can be a big expense for a family with limited means. How can young trees be watered without costing the resident?
Yeah, so that's a really great point. So we found that there is quite a perception that the tree watering can be a cost burden. When we actually went to quantify it, it ends up being, depending on the rates you have, we're talking about up to 15 gallons generally per week, sometimes less as the tree matures, and only for, an establishment period, right? So when we last calculated it, it was about $5 to $7 a year. Now, that's not nothing, so I'm not saying dismiss it. But I think there is a bit of a disconnect between the perception of how expensive it is to water a tree and how much it actually costs. But there are ways to offset that. So, for example, the Metropolitan Water District of Southern California just a month or two ago announced an incentive where residents can receive $100 for every tree that they plant. So there are ways that we can think about how to make that burden less heavy for lower income communities, and how to pick up the bill.
Next question says, love the tree people. What did you do for them?
So I worked for them forever and ever. And the last thing I did for them for the last 10 years that I was there, I ran their research program. So first as a manager and then as their director, but I also worked in the development department and in their projects department. So did quite a few things for them.
Okay, next question.
If there was not only a minimum requirement for tree plantings in both residential and commercial developments, but also minimum standard requirements for tree maintenance, might this be a more effective way to help increase carbon sequestration?
Thank you for that question. Yeah, so you heard me talk a lot about adding more canopy, but what we really need to be thinking of simultaneously, and actually even before that, is preserving existing canopy, and that means maintenance. And so, one of the things that I really hope we're able to make a dent in is reducing the incidence of really poor pruning or topping, which happens. And I can tell you, even city crews sometimes engage in this practice because the pruning cycle is so few, so it's so many years apart that sometimes they have to go in and do some pretty intense, structurally not advisable type of pruning. And so, yes, I think there should be more requirements, not only for reaching a certain canopy, but also preserving that canopy.
And then there's one in chat that says, how have you funded ongoing tree care and maintenance?
We've done quite a bit of research, seeing what the best ways of engaging and incentivizing residents to be stewards of their trees, whether they're on private property or they're right in front of their homes. So I don't know that we've really found a great way to fund it. I think that the answer there is, that these funding streams need to prioritize maintenance with the planting. So planting should only occur if there is funded maintenance. There are different configurations of what that means. It could be hiring crews, or it could be incentivizing residents to do that work themselves in partnership with the nonprofit or the city that is doing the planting. So I think there are examples out there of different ways that that's been done, but I think that there's more work that's required to really find the best way to do that for various communities.
This one looks like a comment, but Dawn says, I have seen areas with high heat and little trees and immediate cooling by using an asphalt topping that reduces heat dramatically.
Yeah. So part of our motivation for in the heat study, looking at not only tree canopy but also reflective surfaces, is that we don't want to suggest that there's just one way to do this. I think we're in such a dire sort of situation now in terms of climate impacts coming faster and more, ferociously than even most scientists anticipated, that we need to be trying all of the, proven methods that are out there. That means trees, but that also means canopies of shade that are not living. That also means reflective surfaces where it makes sense, particularly in roofs. Shade is really, really critical. We didn't get to go into this, but if Annemiek is standing under the shade of a tree and I'm standing 10 feet away in the sun, I can be experiencing a 40-degree, difference. It can feel 40 degrees hotter for me. So shade is really critical, however we're able to provide it.
It seems that a variety of funding / operational sources could help, such as parkways, trails, stormwater, recycled water. What would be the most unsuspected partners that you've worked with?
That is such a good question. I mean, I would say actually, the water agencies, like the fact that the Metropolitan Water District is now offering this incentive, I wouldn't have expected that a water agency would be actually promoting more of that. You see that with certain utilities like the Department of Water and Power in Los Angeles. They incentivize tree planting because of the energy reduction benefits. So that makes sense. The Metropolitan Water District is not a utility in that sense. They're really a water agency. So that would be one example of maybe a non-traditional, unexpected sort of partner, but there are definitely others as well.
Are city planning and development divisions adding this info to master plans?
Well, so our data, particularly like with the mortality study, that did end up influencing documents such as the City of LA's sustainability plan, what they call their Green New Deal for the City of Los Angeles. So yes, I mean, I would like to see more of that, but we are seeing these data being used to demonstrate that these, as I mentioned, sometimes very feel-good types of investments are not just feel-good, they actually produce tangible public health improvements.
What's your thought on planting fruit trees and vegetables in food deserts?
Yeah. I think that there's reasons to engage with urban nature for a lot of different purposes. Heat mitigation is one, but certainly like food security is a major one. That's what I studied for my master's degree, was all about that. I'm a master gardener. I became a master gardener through the UC Cooperative Extension back in the day for that reason. I also think, while fruit trees tend to not provide the same level of shade and typically don't grow as large as a shade tree, they can be a really, really important gateway to getting people connected with the nature outside of their door. And if that's the way that we get people to steward their little corner of the city, I'm all for it.
Have you considered working with the Army Corps of Engineering and their Engineering with Nature program for more funding to implement and support adoption of your recommendations?
I haven't looked into that, but I'll say that I'm now serving on the board of the Friends of the Los Angeles River organization, and they are certainly very engaged with the Army Corps of Engineers, but I'm just starting with that new role. Thank you for mentioning that, and I will look into that as a possibility.
Do the metrics consider wildlife production issues with trees planted near structures?
Can you repeat that one more time?
Yes. Do the metrics consider wildfire reduction issues with trees planted near structures?
I'm not sure which metrics you're referring to, but I think that you're right to point this out. We do have to be thinking about fire risk and reduction of that fire risk, and to be planting in ways that provide shade, but also don't heighten risk. So there are certain species that are more prone to being problematic. The truth is, trees burn, they're made of wood, but certain species are more problematic in that sense. How close you plant also matters. But I'll say that there are colleagues of mine in the cooperative extension that are really, really experts on this topic. And I would recommend availing yourself of some of their resources.
Randall says, I remember hearing at a tree-related meeting a couple of years ago, I heard I heard some people didn't want a tree in their front yard because it could encourage crime. Did that come up in your research?
That is something that we have often heard anecdotally, particularly in lower income communities. So, for example, in Central Alameda, which was one of those 2 pilot communities in South LA, there are a couple of public housing developments there. And unfortunately, there is this, as I said, anecdotal sort of, story of crime being encouraged because, we hear, well, it gives, tree canopy gives potential criminals a place to hide from helicopters, et cetera. From what I've been able to piece together by actually asking where the evidence is for these perceptions, there isn't a whole lot. In fact, there's quite a lot of research that looks at how engagement, sort of civic engagement and urban greening actually promotes social ties and increases social capital to the extent where there are more eyes on the street, more connection within communities and among neighbors, and that it can actually counter crime and other negative neighborhood phenomena.
How do you provide for irrigation for trees planted in the medians, etc., especially within the first year?
Yeah, so I've done a lot less work on median greening than I have on street trees. So street trees are the ones that, line the streets between the sidewalk and the curb. So medians, though, from what I know locally, those are really within the purview of the cities. So you're unlikely to have a neighborhood planting that is, initiated by neighbors and by a neighborhood group that occurs in the median. So the requirement, the onus is really on the city then to provide that irrigation. Sometimes that irrigation is done through automatic lines that are set up for irrigation. Sometimes it will be done via trucking water and sort of hand watering, whether that's done by the city crew or by hired crews.
Are we to understand that cities with high income residencies or residences versus low income cities have the same requirements for tree planting and maintenance?
I don't think that requirements are so much the factor that sort of contributes to the inequity. It's actually availability of resources. So I hope this answers your question a little bit, but what your question makes me sort of point to is the fact that in higher income neighborhoods, even if the onus is on the property owner, the resident, to try to keep that street tree alive, let alone on, of course, on their own private property, you're much more likely to have gardeners that are paid to do this. You have hired gardeners whose job it is to do some maintenance around that tree. That's not true necessarily in lower income neighborhoods, whether single family, sometimes in multifamily residential settings, you do have hired labor that may provide that watering. So I don't know if I've totally answered your question, but I think that's one factor that's really critical to think of, is not so much just the requirements, which aren't in the same city will not be different, right? There might be more protections if there are historic trees, which tend to oftentimes be in wealthier neighborhoods, though not always. But the requirements tend to be the same, but how with the investment and available resources to meet those requirements tend to differ quite a bit.
Dr. Hall talked about growing trees, not just planting trees. In the last photo, the fresh planted tree is left tied to the nursery stake. This is one of the primary reasons for trees failing to thrive. Can your students address this situation / frequency / tree deaths?
Yeah, so absolutely. So that's a very keen observer there that noticed that. So the organizations that do work, you know, with the city of Los Angeles, and there are several nonprofit organizations as well as the city itself that does these plantings, they do follow pretty strict guidelines for how to properly plant. So the nursery stake does get removed. There might be stakes that are placed outside of the kind of root zone in order to provide some stability, especially if the tree is younger. So, you know, I don't know if that totally addresses your question, but planting appropriately and then providing that care, for example, removing the stakes when they're no longer needed, you know, and providing the watering as needed, pruning if required, but oftentimes not, you know, that's all part of promoting higher survival for those trees and a thriving environment in which that tree can then grow and actually provide the protections that we are hoping for as the climate warms up. So I think there are a lot of questions and a lot of sort of research directions that could be explored here. I think that you point a very good one with your question.
With the significant temperature difference between black versus light gray pavement, do you know if LA will be requiring implementation of the latter?
Yes. So yes, we are. So what the city and county have been doing is not only testing some of these pavements to see how they perform, but also changing their ordinances and requirements. So for example, roofs that are now replaced in Los Angeles, both city and county, there are requirements for having those be higher solar reflectance. And so that's something that was first passed. The city of LA was the first in the country to pass something like that, and it's been almost 10 years. And so every time there's a significant re-roofing project or a new construction, there are requirements that are tied to that. So yes, by all means, that happens also to some extent with pavement. Roofs are really more of a slam dunk because they reflect that solar radiation above where people linger. There is some concern around how that reflectance occurs if you are, for example, a kid that's playing in a play yard that has that reflectivity. That reflectance might actually be causing you to have to absorb some of that radiation. So with roofs, though, there's already you know, good research that's really solidly looking at the benefits, and the various jurisdictions here locally have begun to change their codes and requirements accordingly.
When mature trees are removed, is there any review process?
It depends on the jurisdiction. And that process, there might be processes in place, but let me give you an example. For example, I was walking in my neighborhood last year, and I saw that there was a home that had been razed. This is just a couple of blocks from me, so it had, you know, had been torn down. It was clearly getting ready to be, you know, sort of redeveloped. And I guess I saw it before it was raised. There was a sign that said, you know, notice of demolition. And I noticed that there was a mature, really beautiful coast live oak tree. And so I contacted the city and I said, look, I see that there's a demolition that's pending here. Are you aware that this is a tree that is on the protected species list? We have several that are on the protected species list. The city did not know about it. It's on private property. The person that pulled the permit either didn't know to say that or ignored that they were supposed to make the city aware of it. So the processes exist for particularly certain species. They don't always happen. So in our case, we were actually able to save this tree, and we found out there's actually more than one tree. There was one in the yard as well. But had, you know, I happened to not intervene, then we wouldn't have had that. So There are a number of processes in place. One of my colleagues is the city forest officer for the city of Los Angeles, and they have plenty of good things in the books, and they cannot be everywhere. And so there's a steep sort of wall to climb to make sure that we actually offer our existing tree canopy more protection, unfortunately.
Do you mean the planting spec that Urban Tree Foundation provides? Brian Kemp has it free thanks to the CAL FIRE grants.
I'm not sure which planting spec I may have mentioned or what you're referring to exactly, but I for example, and I wasn't thinking what the one that you were naming exactly there, but the ISA, the International Society of Arboriculture, has sets the standard for how trees should be planted, what the proper pruning protocols are, et cetera, et cetera. So I suppose that tends to be the standard that the city and county and others in the profession use. I haven't personally, afforded myself the, sort of option of working with the one that you're talking about. But then again, I'm not an arborist. I just like to hug trees and research them.
I think this is probably a good point. I know there's a few more comments that people made, but I think we should really wrap up. And thank you so much for sticking around, for answering our questions. It's a very interesting topic. Obviously, we've had many wonderful questions, and I also want to thank the audience for sticking around through the whole questioning period. So thanks again, and join us again tomorrow, and have a good evening. Bye-bye.